Welcome back to Road to Mathematics. We've been away for quite some time, but now we're back. Now, this is going to be very different. So if you've got any questions related to mathematics, any level, just write it in the comment section. We're going to provide a platform where you can ask your questions, but for now, stick to the comment section. But today, I want us to look at a topic under radians, arcs, and sectors. The very first thing is first understanding what is a radian, what is an arc, and what is a sector. Now, normally, when you're dealing with secant theorem, you deal with angles, and angles are simply a unit of measurement. Angles are simply a unit of measurement. A unit of measurement. It's the same thing when it comes to solving questions that have to do with a secant when you're trying to understand what a sector and an arc is. So a radian is simply a unit of measurement. Radian is a unit of measurement when calculating questions that have to do with arcs and sectors. But normally we're used with angles. Let's say 180 degrees. The first question would be, what is the equivalent of a radian to an angle? So a radian is equivalent to an angle in a certain way. So in this case, for example, we've got pi radian. Remember, radian is the unit of measurement. This is equal to 180 degrees. Now, note this. Pi is a figure. Radian is the unit of measurement. Similar, 180 is a figure. Degrees is a unit of measurement. So pi is equal to 180 degrees. This is your starting point. This is your base. When you understand this, it will be very easy for you to calculate the arc and the sector of a secant. Now, what is an arc? An arc is a point or a curve on a circle. A curve on a circle, not the whole circle, just a part of the curve. So for instance, we're going to say from this point to this point. This is an arc. Now, I want you to understand something. Circumference is the distance around a given shape, be it a rectangle, be it a triangle, be it a circle in our case. It's the distance around that shape. Now, when you're dealing with an arc is part of this circle. So how do you calculate the distance of an arc from one point to another? Now remember, a circle has got a center. So for us to calculate the distance of this arc that we've made here, we have to connect it to the center. And the center to the circle is what we call the radius. Now we're going to deal with what a radius and a diameter is in a minute. Now, when you have this, how then do you calculate the distance of this arc? The distance of this arc is calculated by this formula. We are going to say arc length is equal to the radius times our angle that is formed by the two radii. So in our case, this is our theta. Theta is the symbol that denotes our angle, hence theta. But not, like I said, we're dealing with the secant theorem, hence everything that we're going to solve has to be in radians. So hence our angle has to be in radians. So if you're given a question and your angle is in degrees, you have to convert it to radians. How do you convert it to radians? We already know that pi radian is equal to 180 degrees. So for example, if they tell you what is 90 degrees equivalent to in radians, so what are we going to do? We're going to say our pi, I'm going to write this here, our pi is equal to 180. We have 90 degrees here, we've got 180. So what is the radian value of 90 degrees? So we're going to cross multiply. So this will be 180. I'll say this is our y, our question mark, is equal to pi times 90. For us to find y, we're going to divide by 180. 180. Hence, This will cancel. Our y will be equal to 0 there, 0 there, pi times 1 over 2. 9, 1, 9 into 18 is 2. Hence, our y is equal to pi over 2. This means that pi over 2 is equal to 90 degrees. That's how you do the conversion. It's very, very easy. Pi radian is equal to 180 degrees. Now, don't forget, our main aim is understanding how to calculate the arc length. Knowing that when calculating the arc length, you have to use your angle in radians. But in any case where you are given an angle in degrees, you can convert it using this formula. Now, the next thing that we have to get here is what we call a sector. Now, what is a sector? A sector is a part that is created when an arc and two radii connect. So this part is what we call a sector. So this is a sector. This other part as well is a sector with that angle here. So the angle for this one is this, and the angle for this other big sector is this one. Hence, if we want to calculate the area covered by this sector, this part here, we're going to say 1 over 2 times r squared times theta. Remember, our theta, which is our angle, should always be in radians. So these are our two very important formulas that we're going to use to solve questions that have to do with finding an arc and the sector, finding an arc length and the sector. To simplify, this is our circle. We've got our center right here. The distance of this point from the center to one part of the circumference, or rather the line of a circle, is radius. And the total distance, like I said, we're going to talk about this, is what we call the diameter. So the distance from here to here is diameter. Hence, this explains that the radius is equal to the diameter divided by 2. Why? Because the diameter is the distance from one point to the other point of the circle passing through the center, and the radius is half of the diameter. And this is our diameter. And then we said an arc is a point on a circle. So a point on a circle, this is an arc, and this is our sector. Now, this is a very interesting question. The area of sector A or B is 150 centimeters squared. I've not written the sector here because I want us to visualize in our heads and write it there. Given that the diameter of a circle is 24 centimeters, so we've got a circle. And we've been told that the diameter of this circle passing through the center is 24 centimeters. This is the distance, 24 centimeters. And we've been told that the area of sector A or B, now O is our point here, so I'm going to write our point here, O. A and B are 2 points of the arc. We're going to visualize it like this, hence our point right there. So here's, this is our sector. Now, if the diameter is 24 centimeters, it means that our radius is half of the diameter. The radius is equal to 1 over 2 times our diameter. In our case, 1 over 2 times 24 centimeters is equal to 12 centimeters. Hence, our radius is 12 centimeters. That's the distance from O to B and from O to A. Having this detail, how do we then calculate our theta, our angle, this angle right here? Our question is that the area of the sector is 150 centimeters squared. Since we know that area of sector is equal to 1 over 2 r squared theta, So this is equal to, knowing that our area of a sector is 150 centimeter, we're trying to find the theta. So what I'm going to do is that I'm going to make theta the subject of the formula. How do we do that? I'm going to cross multiply and say 2 times the area of a sector. I'm going to bring what is on the left side and the right side, and what is on the left side and what is on the left side and the right side. But it's just the same thing. It's just the same thing. So I'm going to say r squared theta is equal to the area times 2. If you get what I mean, this whole expression is the same, is equivalent to 1 over 2 r squared theta is equal to a. And what I've done, I've multiplied the 2 times the a. That's exactly what I've done, and I've remained with the r squared theta. So here, we're going to divide by r squared, because our aim is to calculate theta. So this will cancel, this will cancel. Our theta is equal to a times 2 over r squared. Now, I'm going to write this here so it can be visible. So our theta in this case is equal to, what is our area? Our area is 150 centimeters. 150 times 2 divided by r squared, which is 12 squared. This will be 150 times 2 is 300 divided by 12 squared is 144. Hence our theta, which is our angle in radians, is 2.083 radians. This is our answer. Hence our theta in radians is equal to 2.083 radians. This is our final answer. Now, the next question says, calculate the arc length, or the length of arc AB, this distance here, this distance. So how do we calculate it? We calculate it in such a way that I'm going to rub this off so we can have enough space to calculate. Okay. Arc length, according to our formula, is the radius times theta. Theta, which is our angle. The radius, according to what we've calculated, is 12 centimeters times our angle, which is 2.083. And this 12 times 2.083 is 24.99 centimeters, which is equivalent to 25 centimeters. Hence, our arc length AB is equal to 25 centimeters. And this is how you solve radians, questions that have to do with radians, the arc length, and also the sector. Now, if you've got any question related to such or any other topic, don't hesitate to write it in the comment section. And of course, like I said, we're going to provide a platform where you can ask your questions so that we can solve them together. If you find value in this video, don't forget to subscribe to my channel and share it so that others can also learn. Thank you so much.